so they're not so bad to get through. You also have a calculator step for this, and I'll hit your calculator step in a minute. Because it goes back to z-scores, we also have a p-val test as well as a reject region test, because the p-val you can find using table 4. And this is your test statistic that you'll have, and I'll give you this formula as well. We test this based on the information that we're given, and we see where does it fit. We do a reject region the same way with your level of significance. We can find the p-val assigned to this z-score. We can test your p-vals. We're going to test the same exact way. So consequently, it goes through the same test as this one. Instead of where we verify, do we have n is greater than or equal to 30, or did it tell us it's approximate normal distribution, we test it. N times p greater than or equal to 5, n times q greater than or equal to 5. We still list your claim. We identify HOHA. We sketch. We identify which tail it's in. It's kind of like very repetitious. We go to your table 4. We determine your critical values. These are your cutoff values. These are for your reject regions. We label your reject regions, reject H0, fail to reject H0. We do a test statistic, and we see where does it fall in your graph. And then we make a decision based on that, and we interpret your decision. So it's basically the same thing again, but we use a proportion rather than a mean. And in your calculator, when you do this test, all your tests are sitting up here. So we did a z-test. That was when your population standard deviation was known. We did a t-test when we didn't know your population standard deviation. And now we're doing your proportion. It's this guy right here, 1 proportion z-test. We don't have 2 samples, we have 1. So you can kind of get rid of the 2, because we still only have 1 sample, and it's a proportion. So these are the tests that we're doing for a hypothesis test. It makes life really easy to find on your calculator. All the tests were first, and then remember when we did your intervals? All the intervals came next, and look where your interval sat for this one. 1 proportion z interval. It sat in the middle of those 2's. So do you kind of see something similar? Like we did all these things for intervals, now we're doing all these things for tests. It kind of works the same way. When you do this, it almost looks the same as your other one. It's going to ask you for your population proportion. It's going to ask you for the x and the n. If they gave you the p-hat and the n, you're going to have to just backtrack and figure it out. No decimals in here. Follow your tail and calculate. It's going to give you your z-test statistic. It's going to give you your p-val. And you can test either way. And I'll also give you formulas. If you decide you'd rather do a formula than anything else, I'll give you the formulas. Not a really big topic because we've been doing the same thing. Just go back to z-scores. So let's take a look at a couple examples. A researcher claims that less than 40% of U.S. cell phone owners use their phones for most of their online browsing. In a random sample of 100 adults, 31% say they use their phone for most of their online browsing. At a level of significance of 0.01, is there enough evidence to support the researcher's claim? So support means, which one is it going to be, HO or HA? HA. So we look at the researcher's claim, and sure enough, he says the proportion is less than, now how do I write 40% as a decimal? 0.40. A percent proportion, you gotta give me this as a decimal. So we said this is the claim, and we identified this as the HA. So which way does the tail go? To the left. The tail is going to go to the left. And the rest is going to fall into place. We can label this reject H0. We can label this fail to reject H0. This is our critical value. Will our critical value be positive or negative? Negative. And your critical value is based on what number? Well, how do I find my critical value? 0.01. I look at my level of significance. So how do I find the value related to 0.01? Inverse norm. I go to my calculator. I go inverse norm. Do I have to divide anything? Do I have to subtract from 1? Nope. Good. Paste. Whoops, what happened there? Now I got the wrong one up there. So I get negative 2.33. And am I supposed to be negative? Yes. So that's a good thing. So my critical value is negative 0.233. And my HA, we didn't write your HA. Okay, so now I know everything I need to know about my population statement. I go to my sample. They say for a random sample of 100 people, my p hat is 31. So therefore, what's my x? If I'm going to use my calculator, I need an x. How do I find out the x value? How many of those 100 represent 31%?
31.
31. Thank you, Michael. And then you got that because you multiplied 100 times 0.31, and you moved your decimal 2 places to the left, and you got 31. Yes?
So on the claim, the opposite of the claim, isn't that Q?
Nope, you're still P. You're still P. Right, didn't we use the mean for the other ones?
Yeah.
You still said the mean. You got to give me a complement statement for this guy. HO. Thank you. Yes. I said HO and I wrote HA. Thank you. But this is P hat. This is our test information. This comes from our sample. This is what we're going to test the population with. So this comes from our sample. Remember I did this, population versus sample. P hat. It's the same as mu, x bar. Okay, so we still have to have a pair of equations, inequalities. We have to get our sample information. We didn't really have to find the x, but if you're going to put it in your calculator, you have to find the x. So now, we're going to find your test statistic. You're going to say p hat minus p over the square root of p times q divided by n. Keep it all under one square root on the bottom. So the only thing I'm missing is a q. If my p is 0.40, what's my q? 0.60, 0.6. Okay, so we're going to plug these all in. It's kind of like your mean, your x bar minus your mean. So x bar in this case would be your p hat, your sample, minus your mean, over your information down here. So we'll find this. And again, if you want to use your calculator, I'll show you in 1 minute how to get it on the calculator. Make sure this whole thing sits in the underneath the radical sign. 0.4 times 0.6. And n is how many in your sample. So find your z-score. Now, if we're going to test using your reject region, we want to see where does this guy fall in relationship to my cutoff. So does it fall in the shaded area or the unshaded area? Unshaded. It falls somewhere over here. So what's my decision? Fail to reject H0. If I fail to reject H0, I got to keep this guy. So am I going to support the claim? No. So I find over here, my claim is HA. I fail to reject H0, and I say there is not enough evidence at a level of significance of 0.01 to support the researcher's claim that less than 40% of all cell phone users use their phone for online browsing. Okay, now if I'm going to test p-val, which I very well can test p-val, I need to find the value in my table, the area associated with this z-score. How do I find that area? I look it up in what table? table 4. I look up table 4, and I look up negative 1.84, and do I want the area to the left of it or to the right of it? To the left, that's where I'm shaded, so I look this up, and I get 0.0329. Now, I know this area associated with this cutoff value, I know this area came from my 0.01. So if I want to test p-val, it's the same exact situation, only I say p-val, level of significance. My level of significance, fill it with zeros, and I am greater. And my decision still is fail to reject H0. So you can still do a p-val test. You can still do a reject test, a reject region test. Make sense? Now, if you use your calculator is quite nice for this step 2. Go to your test, come down again. There's your test stuff right up front. This is the only one that has one proportion in it. One proportion z-test. This comes from my population proportion. Somebody put something bad in there? So this is my 0.40. You got to tell them because they won't know what to test against. They want the x, which we already figured out your x. It was 31% of 100. They want your n. And then, again, follow the tail for the HA. So I'm a less than. Now look, they gave you the z-score. They gave you the p-val. This is my p-hat. This p represents my area for that z-score. So this guy right here is my p-val. This guy is my p-hat. It already did my 31 over 100, just to make sure you were on the right track. So this one's quite nice as well. The only thing you don't get from your calculator is your cutoff for your reject region. If it was a right tail test, my cutoff would just be on the positive side. My area over here would be 1 minus that because I want the right-hand side. So just keep track if it's a left-hand side or a right-hand side. And again, when it goes back to a two-tail, what do I have to do with my level of significance to find my reject region? Divide by 2. Good. And when I get to this part, I take that and I multiply by 2. Because we're back on track with your z-scores. Okay, everybody take a minute and do this one. All right, so, Taylor, what's the claim?
P is greater than 0.32.
Okay, is that the HO or the HA? HA. God bless you. What's your HO?
P is less than or equal to 0.32.
Okay, good. What tail test do we have? So, John, how do I find the cutoff value for this guy? The critical value for this?
You have to look at the table.
And what am I looking at?
I did it on the calculator.
Good. So what did you do on your calculator?
That's the one dot c-test.
No. I want this critical value for the reject region.
No, I don't know the region.
Okay, so how do we find... This area says anything that falls in here, I'm going to reject. But if I'm looking at my z-score, this is my cutoff z-score. So that I know where my reject region starts. Otherwise, I don't know where my reject region starts. I don't know how big is this area over here. This area is 0.05. How do I find the z-score associated with 0.05? In your calc, what am I looking for?
Inverse norm.
Good. Thank you for helping him out. Inverse norm. Oops, come on now. Hang. Ugh. Inverse norm. Do I have to divide anything or subtract anything?
1 minus.
you can do 1 minus, and that'll give you the positive, or you can put it in just like this. And if it's a negative, and I'm on the right-hand side, what should I do with it? Make it positive. You can do 1 minus 0.05 also, since it's the area to the left. But try to keep it as easy as possible for yourselves. Okay, so now, I say, okay, I know everything that I need to know. I know my x. Did anybody figure out the x for this? 57. Okay. I know my p hat is 0.38. What's my q over here? 0.7. Okay. I know my n. I know everything else. So now all I have to do is use my formula. If you're a formula person, so p hat 0.38 minus 0.30. Make sure this all stays underneath 0.3 times 0.7, all underneath the square root sign, 150. So what's my z-score? 2.13. So if I'm using the reject region to do this, I'm going to come over here and I'm going to say 2.13 falls over here to the right of my 1.645. That's where I needed this cutoff. It falls in this shaded area. So my decision is reject H0. Now if I did a p-val test, let's do a p-val test at the same time. I take my value, I look this up in my z-score table, and what am I going to have to do with it if I look it up in my z-score table? It's going to be a very large number, isn't it? And I want the area to the right. So when I get this area, I'm going to have to subtract it from 1. Don't I want just the right-hand side of that? Right? The area that's greater than that? So I subtract my area from 1, and I get 0.0162. This is the value associated with this z-score. This was the value associated with that cutoff over there, 0.05 and 1.645. So p-val, level of significance, and I could see that I'm less than or equal to, and I could see that I'm rejecting my H0. My decision is exactly the same. My interpretation says, if I reject this guy, can I support the plane? Try to look at it logically first. Reject it? Oh yeah, then I'm supporting it. So I come over here, my claim is my HA. I reject HO. There is enough evidence at a level of significance of 0.05 to support the researcher's claim that more than 30% of smartphone users use their phone while watching television. Make sense? I'm sure that number has gone up quite a bit. How many of you guys use your phone when you watch television? You know, for social networking or doing something else? Well, not that much, so maybe it's about 30% still. Okay. Most of you sit with your phones in your hands all the time.
Not in math class.
Not in math class. Okay. A researcher claims that 86% of college graduates say their college degree has been a good investment. That's a pretty good amount. In a random sample of 1,000 graduates, 845 say their degree has been a good investment. At a level of significance of 0.10, 10%, is there enough evidence to reject the claim? The word reject means, does my claim have to be HO or HA? HO. So researchers claim that 86% of college graduates say their degree is a good investment. So what's my claim? Equal. Good. And that helps me out. Because in a sentence like that, what do looking for. 86% said this is a good thing. So I know it's an HO. It's got to have an equal sign. Nowhere did they say less than or equal to, more than or equal to, at most, at least. There's my equal to. So P is not equal to 0.86 is my HA. Now be careful. Let's label your graph first. Two-tailed test. You got two areas to share this with. The z-scores are going to be exactly the same for my critical value. But this is the case where you have to take this level of significance and cut it in half. Both have to share 0.05, 0.05. So now, when you look up inverse norm, just do it right in here. If you want to just say 0.10 divided by 2. You could say 0.05 if you wanted to, but why take a chance that you make a mistake? And one is the positive, one is the negative. Okay? Now the flip side of this also says, for my p-val, when I get my p-val for that test statistic, I'm going to have to multiply my p-val by 2. If I divided this by 2, I'm going to have to multiply the other one by 2. So I pull out my test information. And 1,000 graduates, 845 said that they said it was a good investment. I need the p-hat. The p-hat is x over n. They made it nice for us, so my p-hat is 0.845. What's my q over here? If my p is 86, what's my q? One four. So again, p-hat minus my p over the square root of p times q divided by 1,000. I can get this on either side, so make sure you get this in the right position. Now, when I look this up, this area to the left of this number, I have to take this and multiply this by 2, because I got two chances, a left and a right, of getting this to work. This is my p-val, in case I want to test using my p-val. If I want to test just with my z-score, I come over here, and where does negative 1.37 fall? In the shaded or the open? Open. So what's my decision? Good. God bless you. So if I fail to reject H0, that means I have to keep that. So that means I am agreeing with it, but I can't say I agree with it. I come back to my chart again. My claim is my H0. I failed to reject it. So I have to say there's not enough evidence at the level of significance of 0.10 to reject the claim that 86% say they made a good investment with their college degree. I would hope it would be that high, right? I mean, it is a chunk of an investment to make and then not feel that you accomplish something.
Why?
Hmm?
No, why?
No, they're not lies. Okay. So, here's our claim. 30%. Here's our claim. How do I know this is a claim? Because percent, proportion, P. 30% is of U.S. adults have not purchased a certain brand because they found advertisements distasteful. You decide to test this claim and you ask a random sample of 250 U.S. adults whether they have not purchased. Just because they have not purchased, that's part of your statement, so that doesn't make you a not equal. They found the advertisements distasteful. Of those, 90 people, sorry, X says 90 replied yes. So you want to know, is there enough evidence to reject the claim? And yep, my claim is an HO. So your alternate is not equal, that's your HA. So your two-tailed test, again, make sure you label this reject H0, fail to reject H0, and reject H0. So what were your critical values for this?
1.28.
1.28?
Yep. I got 1.645.
645. Is the same as we just did, the 1.645.
1.0.
It's, I got the wrong one?
That was a 4.0. Did you divide it by 2? That's what I got to do.
Oh, we got you guys.
Dang.
Two tails, you gotta share. Two tails,
Wow.
divide by 2. Okay, what did you get for your Z?
No, it's
Your test? 2.07. So what's your decision? Reject H0. Guys, hang on. Sorry, 2.07. If you look this one up, 2.07, you gotta take that p-val, the area, and multiply it by 2 if you're gonna test against your p-val. So you're still rejecting H0. Okay, tomorrow,